Welcome back, students. This is the lab for part 3, and we're following up on the Twitter API. And in this lab, basically, what I want to do is I want to show you guys how to extract more information from Twitter. Now, for the MBAs, this doesn't really matter that much, their skill set, but for the MITA students, this could be very important depending on the capstone project you do. But nevertheless, for the MBA students, you should have an understand. What I'm basically trying to do is I'm trying to show you guys the ins and outs of how APIs sort of work, even though depending on what project you're working on and what social media website you're working on, the library will be different, but the concepts, the framework will still be relatively the same. So that's why I'm going to show you guys this. How do you extract more and more data from an action API, right? In this case, the Twitter API. All right, so we have the code from last week, right? In this example right here, I'm grabbing the status user line from Donald Trump, but I'm going to change this around. I'm going to grab it instead for stock ticker for Twitter, for Tesla. All right, so I'm going to go ahead right here. I'm going to open up a new screen. This is my code from my previous code. So I'm going to open up a new file. And this will be my lab code for lab 3. I'll go ahead and save this. All right. I'll go ahead and grab my basic libraries I always use. And I want to also grab where are you? My Twitter library. Run all this. And my authorization. Now, before I can run the authorization part, this part, I have to obviously run my keys. So I'm going to do that offline again. But basically what we would do is you would have your keys right here and you would run them, but I'll do that offline just so that, again, they're supposed to be private. I'm not supposed to give them out. You guys pretty much have access to them through my code, but you should be using your own code at this point. At this point, you guys should have all your keys should have came through at this point. So I'm going to go ahead and run it. So let me pause the screen for a second. And now this should work for me. So if I run this, I got no error. You have a black dot there because it's like, where's all these other, in this case, I have a black red X there, an error, showing an error because it's saying, hey, where's this variable? Where's this variable? Where are they? I ran them off the screen, so I didn't put them in the same file. I should put them in the same file, but let me at least have the blank versions. Hold on a second. Let me pause this again. All right, I just copied it from the other file. I'm just going to paste the empty versions. I mean, in actuality, when I ran it with the actual keys, but I just kept these here just so the error would go away. So anyway, at this point, the authorization worked, line 19 worked, line 20 works. I'm API, I'm ready to rock, right? And so now what I want to do is I want to get all the statuses or statements made by a certain screen name, in this case, the real Donald Trump. But I'm not going to use Donald Trump anymore. One, the man is just boring at this point. You see that Tulsa rally? Very disappointing. Very disappointing. Right? So I'm going to go ahead and grab a different one. Right? I'm going to go ahead and do it for, scroll over, count equals 200. All right. So instead of the real Donald Trump, I'm going to do it for the subject matter. Actually, I don't even want to do it for the real Donald Trump. So here I do it for, I'm doing it somebody's tweets. I want to change it so I look for at some actually some topic being checked out. So I rather just do, instead of, so this is the code for screen name. I'm going to change this, guys. You can follow along with the slides anyway, but if you want to do somebody's screen name. I want to do actually, instead of the screen name, I want to do the, change this. Let's go here. Oop. Keys again. I want to go here and I want to basically do, I want to get all the data for a topic being trended or talked about. And if you remember that we required the different function, the Q function, which I have somewhere in my code for lab 2, right here, line 79. So let me get this. This is the one I want. Right, so I'm going to change my code up a little bit from my slides. And you guys can follow along any way you want. Let's see if I can get 200 out of this. So instead of Bolton, that was from lab 2, I want to grab all the topics from the topic of Tesla. Now, Twitter, what they did was they made a sort of syntax where if you were looking for information about somebody tweeting about a stock ticker, and the syntax goes like this. If you put the dollar symbol before the ticker, and then the ticker name, in this case, the ticker name for Tesla is TSLA, then you could search for everything, every tweet that is sourcing that ticker, that is basically talking about that ticker. So I'm going to go ahead, I'll name this variable Tesla, lowercase Tesla. Let me run this. Right, let's see if this gave me back any results. Looks like I got some results. Okay, let me normalize it. Remember, to normalize it, we need one more library. This one right here, this function from this library. I'm going to just put it up here on the top, just to keep everything nice and clean. All right. And so df Tesla will be JSON normalize Tesla data container. I run this. Excellent. So it looks like I got something. So there's the statuses. Now, if you guys remember from lab 2, there's a way I can go, because again, so I got a single row, many columns. And in that one statuses thing is basically the JSON norm object that I want that has basically the tweets. So if you guys remember, I showed you guys last week how we can skip a step, right? And normalize the inner JSON object just like this. And now click on df Tesla. And it looks like it just gave me 100 rows. Okay, so the count maximizes 100. All right, cool, that's fine. All right, let's look at some full text over here. See what these people are talking about. Tesla new article, Tesla analyst Gordon Johnson. I couldn't, blah, blah, blah. The one thing about Spider 4, I hate how they cut this stuff off. All right, I couldn't be more bearish. And then he has his own link. Get all the latest Tesla-related news here, blah, blah, blah. So a lot of these guys like to do that blog about tickers. They like to tweet about it and then have a link to their blog. I do this trick too, where they talk about more in detail about the stock ticker. And the reason they're doing it is for promoting their blog. So it's a good way to get traffic. Not a big day today. I have had four or five trades. None of them ran after I wasn't sold. The trades were small. Still using fairly tight trailing stops. I don't trust this action. Have a good evening all. Tesla, Roku, Netflix. All right. We got a little Spanish, Espanol right here. All right. 3 digits or 4 digits to make up your mind. Talking about 1,000 crossing. All right, so that's basically a table of all our the Tesla data I just grabbed, the ticker data. And as you can see, it takes actually more work. If there is a lot of analysis that's done around tweets of stocks, but it just takes a lot more work than we're talking about in this lab because a lot of the content is in the URL embedded in that tweet. So we have to take that URL, if you want to automate this, go to that particular article, and then scrape that site. We'll talk about web scraping in lab 6. And then try to decipher, automate the analysis. Again, you could do that using natural language processing about the actual ticker. So I mean, it's actually can get pretty intense doing kind of analysis like this. And again, this is a whole example of using alternative data to do different analysis. Again, we're keeping it fairly simple here. In this lab, I'm just showing you how to get a bigger data set. That's basically all I'm showing you guys here. All right, so here to count the search tweets, the API search tweets, they allow us up to 100 counts at a time, maximum, as you can see. Whereas if I were to use the API statuses, or the statuses from the user timeline, let's say Donald Trump or any other screen name, it's 200, the max is 200 at a time, 200 at a time, right? So we can see the differences in the shapes right here. I have basically 31 columns and 100 rows, but if you were to do it this way, you would have 200 rows and 303 columns. It's fine. Now, from here, how do I go about getting more tweets? Well, let me first tell you something. This is the free API. The free API that we're using, I believe it allows us up to, I want to say 30, I have it right here, 3,200 tweets, right, of a public account, right? On the topics, I believe it still follows that as well. It might be 1,600 or 3,200, but let's say 3,200 tweets. So if for my Tesla example, or for my PowerPoint example, I got 200 tweets. For my Tesla example, in my lab, in my real-time lab, I got 100 tweets. So how do I get these older tweets? How do I get these other up to 3,200 tweets, right? This is how we have to understand how these actually how the Twitter API works, but in general how all these databases, distributed database systems work, right? Each tweet, if I were to simply do df Tesla, all right, remember df Tesla is the pandas table. If I simply just put quotes and a column name in between, I'm getting all the column values right here of that particular column, all right? What is this ID? What are these IDs? If you can look closer, right? If you can look closer, let me grab the first two values, so just so you can see them. All right, this is the top row one, and this is the one right below it, okay? So what are these IDs? These IDs are exactly what they are. They're the unique description. They're the unique ID for each tweet. Each tweet in Twitter has a unique identification, right? You guys can go on Twitter right now and just say, yo, whatever. That tweet now is a tweet. It's in the database system. It has a unique identification. All right. These are the first two, the row one, row two. This number right here, it's very similar to this number. It's actually not that similar. These are massive numbers, right? Up to this point right here. This number on top is bigger, okay? So what does that mean? The larger the ID, the more recent the tweet. The smaller the ID, the older the tweet. This is how it goes. As new tweets are coming, they just get the next large, whatever this friggin' crazy number is, right? And this gives you an idea how many tweets are out there, right? Talk about data, right? It's insane. So what that means is now I'm going to go scroll all the way down and get the very last, the 100th tweet that I got in my first go around. And that is that value right there. So this is the most recent tweet up here, second most recent tweet, and this is the oldest tweet that came back in that block of 100, that block of 100 data, okay? Knowing this and understanding this is how we're gonna get older tweets. That's how we're gonna get older tweets. Now, I could go ahead and store this older tweet value in a variable called MID, minimum ID if you want, by just using the min function. Bam. And if you see it, it'll be the same value as this value up here in line 29. All right, so I have this variable now, MID. I don't know why it does this stuff. Let me delete this. I have to read about the new spider for why they still have these random X's out of nowhere. Like, there's nothing going on here. What's the problem? You know what? Maybe it doesn't like this. Hold on. Let me comment this out. Is that better? Is that better? No, still has that error there. Let's just move on. So misleading. All right. Okay. So what am I going to do with that minimum ID right there? What's going on there? How am I going to use it? The logic here is this. All right. I can use an additional parameter up here. I'm going to call this Tesla 2. Oops, sorry, not Tesla. Tesla 2. I'm going to call the tweets again, but this time I'm going to have an additional parameter called max_ID that I will call. You can use it in the user timeline one. You can use it in the tweets one. Same thing. Max. They both have it. Max_ID. Scoot this over. And what I'm going to do there is I'm going to place an ID. The ID that I place in there, what's going to happen now is this function now will get not the latest 100 tweets on this particular topic. No, it'll get the latest 100 tweets on this particular topic that are less than or equal to the ID that I placed there. I'm going to say that again. When you place an ID number here, right? Let's say hypothetically I would place the minimum ID number right here. Okay? Now what's going to happen is this function is now going to get the latest 100 tweets on this subject where the IDs of those tweets are less than equal to that ID. Less than equal to that ID. How does this help us get more tweets? Because now we can get the next set of 100, right? Now we can get the next set of 100. The logic here, people, is like this, right? If I were to open up an Excel sheet, all right, and forget we're using hundreds, right? Let's say our function only did tweets of 5 at a time. Let's say I had a tweet. There's a total of, on the subject of apples or something, there's like, well, let me do this in reverse. 100. All right. So assume that this column right here is the IDs of these tweets, all these different tweets. And let's assume I'm getting them a 5 at a time, right? So instead of 100 at a time. So the first 5 tweets that came back would have had these IDs, right there. What we want to do is we want to grab that last ID, and we want to now put that ID under max_ID right here, or right there, right? And then select the next 5. The problem here is the way max ID works is it gets the 5 most recent IDs less than or equal to the ID you put in. If I simply put this ID in, then I'm going to get this ID back again, right? It's going to, the first row is going to be that particular ID 96. I don't want that. I don't want repeating. That is why over here you see me do something very strange. You see me get the minimum ID, and then you see me decremented by a number of 1. Why do I do this? I do this so I could put this variable in here and get something less than equal to this variable to ensure that I will not get the 200 tweet again as the first tweet. That's why I do that. That's why I subtract by 1. Because again, the way that parameter works is it gets the most recent tweets less than or equal to the ID you give it. If I simply just give it this ID without subtracting 1 from it, of the last tweet I get, the 200 tweet in this example, or in this example, the 100 tweet, right? So let me go ahead and do this. Then I'm going to get this tweet again as my first tweet in Tesla 2, in this second set go around of getting the IDs, right? So that's why I will do mid equals mid minus 1. And you can check for yourself that that number has dropped by a mere 1. And under max ID, I will put that mid right here. Okay, I will run this function again. I get another object called Tesla2, JSON object. I'm going to go ahead and normalize that into df Tesla2, right? And that will equal JSON normalize Tesla2, comma, statuses. All right, now I have two tables, Tesla2. Okay, now look what I'm going to do. All right, I already have the minimum ID from my first set, from my most recent set, which is under df Tesla. That's that number. Now let me get the, I'm sorry, this is the oldest tweet from my first set of Tesla data I got, which is the most recent one. All right. Now let me get the maximum one, which is the newest tweet from the second block I got, right? Which is going to be simply df Tesla2.max. Oh, sorry. .id.max. I can use the syntax too, remember. All right. So this is the min from the first set, from set 1. And max from set 2. And again, the minimum represents the oldest tweet, the maximum represents the oldest tweet from set 2. I mean, the newest tweet from set 2. Which one's bigger? They're the same when it comes here, 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 here. Boom. And then here they're different. The one on top, where it's to say the smallest ID from set 1 is larger than the maximum ID from set 2. Why is that? This is because this tweet is older than that tweet. This system worked. Basically, what we did here is we got the smallest ID from here, which is 96. We subtract that by 1 to get 95, stuck 95 into that function under max ID, and got the next set of 5. All right, I'm going to then take the minimum ID from that second set, decrement that by 1, stick that back into max ID, and get the next set of 5. And so on, and so on, and so on. That is how we keep going, doing this, until we get up to 3,200 rows of data. In some cases, you can go over 3,400. I mean, the API tends to be a little loosey-goosey in its constraints, right? But that's the logic. That's how it's going to work. All right, that is basically how it's going to work. Right, so what are we basically creating? We are creating a for loop. If I were to keep doing this over in the logic over and over again, now I'm going to create a df Tesla 3. I'm going to take a mid 2. All right, take df Tesla 2.id.min, get the smallest one there. Subtract that bad boy by 1. And then I'm going to go ahead and I would go ahead and do Tesla 3, do another round of this. But this time put in mid 2, right? And go on and on and on, keep doing the Tesla 4, Tesla 5, Tesla 6. So what am I doing, guys? You're creating a for loop. Here is the for loop. I have the solution right here. We're going to construct this ever so slowly, all right? We're going to construct this ever so slowly. But before we do this for loop, I will do something similar to this, all right? I need to show you guys the concat function. Because what's going to happen here is, let's say, let me go ahead and grab this. Let me go ahead, grab this, right? And let me put this in a for loop. How am I want this to run, let's say I have 100 tweets, I can go up to 3,200, so I want this to run 32 times. Guys, how do I get this loop to run 32 times? Who remembers? For I in what? Just use the range object. That's it. If you guys remember, right? The range object, this will go from 0 to 32, where 32 will actually from 0 to 31. And I will just run, this will just run 32 times. It does not matter that we're not going to use the I variable, right? That's irrelevant. This for loop will run 32 times. The problem is when we run this Tesla object and then we run this JSON normalize, right? I have this table called df Tesla. But the problem is the next time I run it around, right, with the new, let's say with the new min-max ID, the table will get overwritten. I need another master table that keeps concatenating these smaller tables into it, right? Because listen, I have a df, like in this example, I have df Tesla here, df Tesla 2 here, I'll have another df Tesla 3 after that one, and so on and so on. So these tables need to be concatenated into a larger table when you're dealing with the for loop. It has to happen during each loop because df Tesla will always get overwritten to be the next set of 100. Enter now the concept of the concat function. So here I'm going to show you this cool little concat function from Pandas library that basically shows you how you can concatenate tables. All right. So here's a simple example. Let's say I have this series right here, A, which is 1, 2, 3, 4, 5. Another series B that is 10, 20, 30, 40, 50. I have another series C that is 6, 7, 8, 9, 10. And then I have a series D, which is 60, 70, 80, 90, 100. Okay? So here's your series right here. You have A, B, C, D. All right? Now, using these 4 series that I created, I'm going to create a table, 4 different tables. Well, the first tables I'm going to create is DFA and DFB. DFA is simply going to be the A and the B series. Nice and easy. The DFB, though, will be simply the C and the D series. All right, excellent. Then what I'm going to do is I'm going to call this concatenate function from Pandas and combine DFA and DFB into this table called DFC. And then I'm going to create a new table called DFD. That's the combination of DFA and DFB again, but with this additional parameter called ignore underscore index true. I give you guys one hint what that function does. When all is said and done, these are the tables that are created. So DFA is A and B. That's the first column here, 1 to 5, 10 to 50, no problem. DFB is this table right here. Again, that's the C series, and the D series, which was 6 to 10, and 60 to 100. DFC is this table right here. This is where we concatenate the DFA table and the DFB table. Notice how it's concatenated. When we say concatenate, it's literally stacked on top of one another. And the way the stacking happens is left to right. So this is stacked on top of DFB because this is to the left of DFB. Therefore, this stacks like that on top of DFB. And this is why you have this table right here, DFC. As you can see, the first 5 values are from DFA, 1, 2, 3, 4, 5, 10 to 50. The last 5 values are from DFB. But notice the indexes. When you stack them, the indexes were preserved. See that? The original indexes were preserved. They didn't get overwritten. Whereas in line 4 over here, when I do the concat function, I had an additional parameter called ignore index equals true. You guys pretty much know where this is headed. This is the DFD table now. Same thing happens. We stack DFA right on top of DFB, sit it right on top of DFB. But the only difference is here, the indexes now are reset. Every time you do the setting, it's reset. So that looks like more of a normal table with the series going from 0 to 9 in an incremental order, as opposed to repeating. So now we want to go ahead, go back to our for loop and construct this for loop, this monstrosity, right? Mine is obviously going to be different. I'm not looking at user timeline. I'm looking at actually searching certain subjects of tweets or hashtags, Tesla in this case. But the overall construct is the same. Now, if we come back here, all right, we come back here, we start off with the first Tesla search I do. All right. And we normalize this table. Done. It's at this point that outside of this, I'm going to create an empty table. I'm going to create an empty data frame. All right. And that's what you see here in line 1. I call it here a df. I'll call it df all in this case. And it's literally just the parentheses. I run this, and now you'll see a variable here, df all, in your top right screen. And you'll notice it's a data frame. The size is 0, 0. It's literally empty. Like if you were to type in df all over here, it literally says nothing in the columns, nothing in the indexes. It's an empty data frame. All right. From here, we want to institute what we did before with the concatenate, right? But it's going to be slightly different. It's going to be slightly different. Here, I'm going to have df all equals pd.concatenate. All right. In brackets, I list the 2 tables that I want to concatenate. And here, where it's going to be slightly different from our slides, in my example, the example in my slide, because the first table is going to be the same table, df all, and after that will be that small table, the mini table, df Tesla. And of course, I'll have ignore index equals true. All right. And what will happen is now when I run this, okay, df all will concatenate each time. Now, again, don't be concerned that here we have df all and here we have df all. Remember, you have a single equals here. When you have a single equals, a data container is being changed or modified. In this example, it's being modified. And when it's being modified, there's an order of steps. The right side happens first. So what happens here on the right side here is whatever's in the df all at this point, it'll stack it on top of df Tesla, all right, and create a whole new table. So let's say there's 1,000 rows in df all, 100 rows in df Tesla. It'll stack it and create a new table of 1,100, and that new table will then overwrite the previous df all. So after the whole line is run and done, df all will have appended that bottom table, right? It will have appended that bottom table because it's always just rewriting itself. It's always concatenating and then overwriting itself. So that's the logic. Now, from here, what's the problem? The problem is every loop we do, again, it's going to run 32 times. It's going to run 32 times. Every loop we do, it's going to be the same most recent 100 tweets. You remember here, we did this whole song and dance of getting the smallest ID, decrementing it by 1, and then using this new parameter called max underscore ID. Right? We're not doing that here. You see, this function, this part, we need to do just the first time. After that, we need to do this one. It's going to cut off here a little bit. But we need to do this one right here. So I ask you now, how in a for loop would we run one set of code in the first instance and then another set of code in every other instance? Anybody? Anybody? If you said if else, give yourself a cookie. You're correct. Right? So what will designate, what's the easy way to designate the first iteration of the loop? The first loop of all 32 loops. How do we know? Well, remember that? Remember the iterator? In the first loop, what is its value going to be? It's going to be 0. Therefore, if I equals 0, then remember Python is a tab-based programming language. Then run this code, and then run this code. Else, right? Else, for all other situations where I is a different value, I'm going to change this back to Tesla. Run this code right here. All right, we want to run this code right here. Okay, not bad. So it's getting a little bit better. The only problem is here, we don't have an MID variable in here, right? So what I'll do is I'll create one outside here, call it 0. And on the first loop, I'm going to give it its value, which is going to be, we have that right here as well. Right here. All right. It's going to get the MID value. It's going to decrement it by 1. It'll do the concatenation. And now in the next loop, I will now be the value 1. So this whole part will be skipped, and it'll come down here to the else. In the else part, it's now going to, instead of running the first 100, it's now going to use a max ID to get the first 100, which is less than or equal to that MID, which we did in line 52. So now I'm going to go ahead and copy. This will happen. I'm going to want to normalize that table. And then once I normalize that table, I want to concatenate it. But before I do that, I want to get the new MID. Decremented by 1, so that I have it for the following for loop. Right? And every time now else, only the first time this code will run here. Everything after that will run here. And now MID, we don't keep decrementing MID, getting the new MID and decrementing by 1. So that every time it runs, it keeps going back and back and back in the past. And here, of course, we're going to have this part right here. Right? And then after this, we should be done. We should be done for the most part. We should be done. Now, a couple points. Notice this line and this line are exactly the same. This line and this line are exactly the same. This line and this line are exactly the same. And this line and this line is exactly the same. In fact, whether it's the first loop or every other loop, these lines, 4 lines, must run. If that is the case, then why don't I just run it every time? So I'll delete it here. I'll delete it here. And then from here, I'll delete it here. And then I'll delete this right here. I'll delete it here. And here now, so this will run. And watch what I do now, guys. See that? See what I did? I moved over, so I deleted those 4 lines from here, and then I tabbed over these 4 lines after the else. All right? Now, because they're tabbed in, what ends up happening here is, in the first loop, when I equals 0, this one runs. Else does not run. The only line in else now is what's tabbed underneath it. This is the only line tabbed underneath it, so this won't run. Everything else, notice the tab spacing. It belongs to not the else, not the if, it belongs to the for loop. So every time that for loop runs, these 4 lines will run. It's just that this will not run first for the first loop, and then these 4 lines will run. And every other time, this line will run, and then these 4 lines will run. And that's how we took out that code, right? And so now we're pretty much almost done with what we did here, but I add this additional checker over here. What ends up happening here is, let me go ahead and run this. Let me go ahead and run this now. As I twiddle my thumbs and it's running. Still running. I'm going to go ahead and pause it while it runs. Oh, it's finished. It's done. All right, now let's look at DFL up here. Look at that, 3,182 rows and 31 columns. So it looks like I couldn't get 3,200 rows. Looks like it blocked me at 31,832 rows. All right. So let's just confirm this. Let's look at the 99th row of full text. Remember, that's the 100th row. And look what it says. It says, please pay attention at Nicola Trevor. This is how you pump with artistic impressions. Tesla, Nicola, and then obviously it has a link to something. All right, so somebody's also promoting something. All right, so let me now go to the last row, which would be 3,181. I mean the last index, 3,181. And you see it's a totally different statement. U.S. electric vehicle Q2 2020 update, competitive dynamics between Tesla, Rivian. Rivian is another company that Amazon is backing to build some delivery trucks or something like that. Legacy auto OEM, shutdown costs, factories fixed versus variable costs. And again, there's another YouTube, not YouTube, like some sort of other URL link for you to go ahead and check out, right? So I believe there's another column. There could be another column that has a separate links separately. We can double check that later. But so anyway, it worked. It worked. Now, if you were to use the other function, right, the API search, this one right here, the user timeline, I believe this lets you keep going and going and could give you an error. So I'm going to try to get an error here using mine. Instead of going 32, I'm going to go to 36 and see what happens. I will pause it in the meantime while that runs. I'm having trouble pausing it. All right, looks like it ran without an error. And it's still, for me now, when I'm looking at it, I'm getting 3,578 rows, which shouldn't be the case. It should be capping me at 3,200. I'm going to go ahead and try to see if I could do run it 4,000 times, see what happens. Let me run this and I'll pause it again. All right, that's not working. I'm not getting an error there. In fact, I got more now. I got 3,980. So maybe I could keep pushing this. I don't know what's going on with Twitter. Eventually, they're gonna give me some sort of error saying you can't keep taking so many. But anyway, the logic here is with the if-else check here, right, from lines 8 to 12 in my slide, is basically about that the JSON object that comes back, which is df Tesla in this case. No, where are you? Tesla. The Tesla object that comes back from the API function, from the Twitter API, it's a JSON object. Well, if that JSON object, right, if that JSON object, Tesla, is not greater than 0, actually, we don't want to do any of this code from lines 52 to 57 if the length of that JSON object is not greater than 0. If it's not greater than 0, then there's nothing in it. I mean, if it's 0, there's nothing in it. If it's greater than 0, then I obviously have some data that I can normalize and I can move on with my life. But if it's 0, that means nothing else is coming back. And that's how I prevent an error from happening. So that's basically why that if statement is there, right here. That's why that if statement is here. And now you guys see where it comes from. And this is basically how we construct that for loop. And this is how you take the API that a social company or a third-party company, social media company gives to you, and you can manipulate it legally. This is how they want you to use it to get older data. Now, the great thing about this, right? Again, if I'm from the financial world and I want to see the tweets on a certain stock or a bunch of stocks, I can have code that just runs every, I don't know, 20, 30 minutes. This is the free API. But I can have the code that runs maybe an hour or maybe every day. Who knows, right? And I can keep getting these tweets and store it in a database. And then I could do the analysis even further from there. I get it, store it in a database, take just the text I care about, That's actually really what I care about, text. And in the case of all of these, a lot of these stock ticker ones, they have usually URL codes that lead to other blogs or videos, whatever. And you can try to isolate which users or groups are sending more relevant tweets, right? And you can start focusing on them and see how they move, especially if they have a lot of followers. And we know if they have a lot of followers, we can use the API to check that. We can see how if they move the market. You see this happening now with Robinhood. I don't know if you guys saw this, but Robinhood is that app that, it started off with free trading, but now that's gone out the window anyway because Ameritrade, everybody's free now. But it started with Robinhood. I give them credit for it. Commissionless trading. And Robinhood has APIs where you can search at an aggregate level what people are buying, all these retail investors are buying. In the news recently, there's been this whole hubbub about the fact that hedge funds have been losing money respective to, all these retail investors. Like the investors in Robinhood are getting it right. The hedge funds are getting it wrong. Hedge funds are getting it wrong because they're being rational. There should be a recession. These stocks should be going down, but they're not. Whereas Robinhood is getting it right. So the new thing now is, not the new thing now. It's been happening a while, but there's a light shining on this. Is that because of the fact Robinhood gives this API so that people can see what's being traded. These big hedge funds are using these APIs to see what retail or smaller investors are interested in, and then making decisions based on that. Same concept here. Right? This is an API for Twitter. That would be an API for Robinhood, and obviously it would work differently, but functionality is functionality. You just have to figure out what functions they give you and what those functions do, just like we did here. And you can build your data sets and take it to the next level and start analyzing it. Now, from here, guys, right, we're pretty much done. And at this point, I open this up to Lab 4, which I will post, but we will not do this semester because we just won't have time. I didn't finish it last semester, so I won't try to push it on you guys this summer. And the reason being because I want to get to Lab 5 and 6, right? But nevertheless, Lab 4 has some cool things in it. So Lab 4 opens up talking about natural language processing. Natural language processing is basically the science behind analyzing the text, the context of any kind of written statement, verbal statement, written on a text or recorded in some sort of audio or video. It doesn't matter. It's one of the largest subfields within data science. Massive, right? The applications are endless. There's a video out there. If I find it, I'll post it on Blackboard for you guys to see, where the Google engineer CEO is basically talking what it sounds like a person. That's not a person. That's a machine. And the conversation seems very human-like. Why? Because one, they're using machine learning on the one end to basically learn how to talk more and more like a human being, and two, natural language processing to basically dissect the code while somebody's speaking, his words, understand what they're talking about, and then respond accordingly. There's a cool little package, and this is in Lab 4, you'll see it, called TextBlob. And that allows you to, TextBlob right here. And that is a very simple, basic natural language processing library in Python. You have to download it. I'll show you guys it's in the slides. You guys will see it. And it's cool in a sense because you can do what we call sentiment analysis. Sentiment analysis is basically where you can say, hey, is this a positive statement being made or a negative statement being made? And if you isolate the nouns, the either proper nouns within the statement, you can say, okay, this proper statement is most likely being talked about in a negative point of view. Like, for instance, let's say the word Trump. There may be a proper noun Trump in the statement. And the statement overall is considered negative. And the statement overall is considered subjective rather than objective. The difference between subjective and objective is something that is opinionated versus something objective, which is fact-based, right? Unless you're on Fox News, apparently, Kellyanne Conway, everything is subjective. So anyway, so that's the whole idea behind it. Also in Lab 4, I do a little cool thing. I use word art. I show you guys how to do a word graph. A word graph is a real cool thing where you make a graph out of words, and it has different word cloud. So I show you guys that too. There's a cool little library that makes you do that. So it's a fun little lab. We just don't have time for it because I want to jump into lab 5. I mean, obviously, I want you guys to jump into lab 5, where we really start we start crossing into machine learning. And we really start talking about predictive analytics, which is what business analytics is all about. It's a little bit of a mind bender, that lab, but it's kind of cool. It's kind of cool. All right. So I'll post up the stuff for lab 4. It'll have the text blob examples in there. You guys can check it out on your own. It has the word cloud stuff. But for this lab, we're pretty much done. It's a short one, and I'll see you guys on the next Q&A or video session. All right, bye guys.